so today we're going to just do the examples so that we can remember what we did yesterday. All right, so I need you to open up your books. Whoops. To page 473. Let me zoom in a little bit better. Is everyone there? No, I'm still waiting. I said open up your books to page 473. Are we there? All right, so we're going to follow directions. All right, so let's look at number 7. We're going to start there. It says simplify the following radicals. Square root of 75. Okay, so what do we do first? Gabby? Factor tree. All right, so what two numbers, when multiplied, give us 75?
3 times 25.
3 times 25. Think of it as quarters. 3 is prime. And then we have 5 times 5. I'll throw that away later. There goes another pen. Thank you, Emily. Okay, so then I said you write out your factors from least to greatest. And our pair, we circle our pair. It goes on the outside. And we only choose one out of the pair. And then the leftover goes on the inside. So then the answer is 5 times the square root of 3. Are there any questions? Michael, do you have this written down? Good. Yes.
I think you said it yesterday on the notes, but what happens if there's no pairs? Like there's no.
Then it's just going to be like a regular number.
Oh.
It's probably going to be a perfect square. Are there any questions?
Wait, what? Even if they're all different numbers?
Yeah, it's all going to be on the outside.
Oh,
Okay. Any questions? Any other questions? All right, let's see. So you get that. Let's move on to 13. Square root of 2 times the square root of 3. Michael, what would that be?
2 times 3 squared. Which would equal to 6 squared.
Square root of 6. 6 squared would look like this.
Oh, yeah.
So we're going to say the square root of 6. Can we simplify that anymore? Like,
Yes.
Wait, isn't it called square root because
okay, Taylor, this is Michael's turn.
Yeah.
We can? So do we need to do a factor tree?
Yes.
What do I get?
Oh, wait, no, you can't.
Okay, he's correct. You can't. Because do I have any pairs?
no. Oh, I'm sorry.
Do I have any pairs?
No.
Okay, so there's nothing that can go on the outside. So therefore, these would go on the inside anyway. So nothing's changed. So it is simplified as far as it can go. Okay, do you have a question?
isn't it called
Taylor, do you have a question about the work we're doing? Is this a legit question?
it's a question about why it's called square root?
Because we're dealing with squares. Okay, I want to move through this because we're short on time with Spanish and chapel, so I want to get through the actual work, okay? Then you and I can talk about the name in a little bit. Okay, any question about this? Let's see, let's do another one. let's do let's do no, I don't want to do that one. Let's do 15. 6 square root of 6 times square root of 3. Izzy. Okay, so you can do this in one of two ways. You can either do what she's saying, 6 times 3, which will get you what? Square root of 18. Now, is that simplified, or do we need to see if we need to simplify it more? By doing what? Yeah. You're asking, you should be telling me. All right, so we're going to do a factor tree. See if we can factor it more. So what two numbers? Give me 18, Izzy. Very good. And then I had 3 times 3. All right, we're going to write the factors. Now tell me what to do, Izzy. So could this have been factored more? Yes. All right, so what do I do now? All right. And how do I write my answer? Very good. And 2 on the inside. You are 100% correct. Because the leftover goes on the inside. The pair goes on the outside. Now, you could have done it in a different way. Because these are multiplying, you could do a factor tree for both, basically. This is already prime, and this would be 2 times 3. Do you see that? You could have done a factor tree for both and done the exact same thing.
Then immediately find it.
You would, yes, exactly. You can find it that way. So what I'm saying is you can do one of two ways. You can multiply like they've done first and then factor it out, or you can factor both and then get your answer.
Can you do that with every problem, or does it just like...
No, any problem. Like, let's see. Look at 19. Let's do another one. Does everyone have this down?
Yeah.
19 is the square root of 21 times square root of 30. And Izzy, you did a good job, by the way. You and Michael are doing great. All right, so in this case, man, if you were to multiply it, 21 times 30, man, that's getting ugly. So I would do your factor tree for both. What two numbers give me 21? Very good. Thank you, Emily. And then, Cecilia, what two numbers give me 30?
3 times 2.
Awesome. And then, of course, we have 2 times 5. So then if we write our factors out in order from least to greatest, and don't forget to cross them out, and you are all writing this down. And because we multiply everything and we're multiplying in the problem, we just write them all down. What are my pairs, Whit?
3 and 3.
So here's my pair. These are going to be my leftovers. So then what I have is the 3 goes on the outside, and then the 2 times 5 times 7 go on the inside. And 2 times 5 is what, Aiden?
10,
And 10 times 7 is?
70.
And we have simplified it as far as we can go. Any questions? Any questions? I got one more to do for the multiplication, then we're going to move to division. Look at 21. It's a little hairy. 5 times the square root of 6 times 2 times the square root of 14. So that's 14. What's crazy about this one are the 2 numbers on the outside. Who remembers what do I do with the 2 numbers on the outside, Gabby? That's right. We're going to multiply the 2 numbers on the outside. What do I get? 10. So that's the first thing I'm doing. Multiplying the 2 numbers on the outside. Okay, so now I'm going to factor tree the 6 and the 14 and do like we did up here. My 2 numbers that give me 6 are the obvious ones, 2 and 3. And then 7 times 2 gives us 14. Are y'all with me? So then I write my prime factors out in order from least to greatest. Michael, what do I do now?
You circle the pairs.
Which are?
2.
And then these are my leftovers. Where does the 2 go?
Next to the 10.
Okay, next to the 10 on the outside, what am I going to do with it? Add it?
Multiply.
You are 100% correct. I'm going to multiply it with that 10. And then, of course, our 2 leftovers go there. 3 times 7. So the answer is 2 times 10 is what, Emily?
20.
And 3 times 7 is what, Michaela?
21.
And there's your answer.
21.
That's what I was thinking of.
All right. How are we feeling so far?
Perfect.
Good.
Pretty good.
Y'all have this down?
Mm-hmm.
Izzy, do you have it? Okay, good.
I feel like I understand it now, but once we have to do it on our own, I'm going to be so
Well, then
lost.
you've got your notes. That's why I tell everyone to take good notes. Okay, let's look at 23 on the next page. I have the square root of 30 divided by the square root of 3. Cecilia, are these perfect squares? None of them are. So I'm rewriting it all under the big radical sign. 30 divided by 3 is what, Aiden?
10.
Very good. Guys, it's still under the radical sign. Remember, you can't get rid of the radical sign yet. Just because you divide it doesn't mean it disappears. I guarantee people in here are going to do that. You cannot get rid of it unless you square it and do all kinds of stuff. So then you got to see, is this simplified all the way? You can check by doing a factor tree. 2 times 5. Yeah, there's no pairs, so this is simplified all the way. Any questions about that problem? $25. I have the square root of 9 over the square root of 81. Izzy, are any of these perfect squares? Which ones? Both. That's right. So Izzy, what is the square root of 9? And Izzy, what's the square root of 81? Can this be simplified? What would it be? She is absolutely 100% perfect. Does anyone have any questions as to where she got 1/3? With?
Oh, why would you take the radical sign out?
Because what is the square root of 9?
3. Oh, wait, so if you have a perfect square, then you can take the radical out?
Exactly.
Okay.
Like, for example, square root of 4 is?
2.
There you go.
What if it was 7 or something? Okay.
Okay, perfect squares only. Only if it's perfect squares. Like, this is that square root of 4 is perfect square. What about 25? What would that be, Michaela?
5.
There you go. Those are perfect squares. Perfect squares mean 5 times 5, 2 times 2, 3 times 3, 9 times 9. Those are perfect squares. Does that help?
Well, I was asking what we'd do if, like, the top number was 7 and the bottom number was 8. And 7 isn't a perfect square.
Then we would work that out completely. Well, like this, you would see if you can divide, or then we can simplify it more. This, you would still come to 9, but then this would have to, like if this was 7, it would stay square root of
But
7.
do you think we'll have to deal with that?
I don't think so. Let's look at 27. Ooh, that's different. 5 times the square root of 10 divided by a square root of 2. Okay, this has a number on the outside. That's kind of crazy. Are these perfect squares?
No, ma'am.
No. Are these
yeah,
perfect
yeah.
squares? Okay, so we're not going to look at this 5 right now. We're going to look at these 2. Can these be divided?
Yes.
So the square root of 10 divided by the square root of 2 is what?
The square root of 5.
So then it's
5 times the square root of 5.
perfect. 5 times square root of 5. See, that number basically is just going to stay the same because 2 can go into 10 evenly. This can't be simplified anymore, so there's your answer. Any questions? Let's see. Let's do 31, and then I'm setting you free. It is 2 times the square root of 80 over 8. Now, question. Is 8 in a square root?
No, ma'am.
Look here. See how the 2 is in a square root here? So we could divide these 2. And we got that. 8 is not. But the 2 isn't either. So can we simplify the 2 and the 8?
Yes, ma'am.
Emily, what would it be? Yes, Emily, you're correct. It would be 1 times square root of 80 over 4.
You have to write the 1.
You do not. In fact, I'm going to rewrite it because you don't have to write the 1. It'll look like that. Okay, now what we would do is do the factor tree of 80. So what 2 numbers, when multiplied, give me 80?
20 times 4.
20 times 4. And 4 would be 2 times 2. 20 would be what?
10 times 2.
And then 5 times 2. So I'm going to write out my factors. One, 2, 3, 4, 5. 1, 2, 3, 4, 5. Here's my pairs and my leftover. So my two pairs go where? On the outside. And then my leftover goes on the inside. So I'm left with 2 times 2 on the outside and 5 on the inside. Does everyone see that so far? And I carried over the 4. It's still down here. Cecilia, do you see that? So then what's 2 times 2? 4 times square root of 5 over 4. And Cecilia, can I simplify these two 4s? 4 divided by 4 is what? 1. So that's basically 1 times square root of 5, which is just square root of 5. Are there any questions about how we did that?
You don't have to put the 1 under?
No.
No?
Because that's just same as a whole number. Alright, so I'm going to set y'all free. Y'all can work, now and after Spanish. You may not, need to, but just in case. Does everyone have this down? Alright. You're going to do page 473 to 474. You're going to do numbers 8,
7.
What?
8 through
32 even. That's 13 problems. Due Friday. And your, where is it?
Thank you. That's not a lot of
Your
problems.
exam is
Thursday.
tentatively Thursday.
What does tentatively mean?
Maybe.
Oh, okay.
Yeah, it's probably going to be Thursday.
I have a question.
So your 6 weeks exam, it's going to cover chapters 10 through 11. It's going to be Thursday.
That's 2 chapters.
What exam is Monday?
That's amazing.
You have history on Monday. You need to look at y'all's board, the test board outside.